Picture a world where zero does not exist, where complex calculations collapse under their own weight, where astronomy stalls, and where modern science cannot even begin. Now imagine that missing idea quietly taking shape, not in Europe, not in the modern age, but in ancient India, long before calculators, long before computers, changing human knowledge forever. This story unfolds across the Indian subcontinent over many centuries, from bustling cities along the Indus to scholarly centers like Ujjain and Nalanda. It is a place where trade, astronomy, religion, and philosophy all demanded precision. Counting crops, tracking planetary movements, and building calendars were not abstract exercises. They shaped daily life. Mathematics here was not locked away in ivory towers. It was a living tool for understanding the universe. Before this transformation, much of the world relied on number systems that were clumsy and limited. Roman numerals, for example, worked for simple counting but struggled with multiplication, division, or large calculations. There was no clear way to represent nothing, no efficient method to write very large numbers, and no simple way to perform advanced arithmetic. As societies grew more complex, the challenge was clear even if it was not yet named. How do you represent absence? How do you calculate efficiently without rewriting entire symbols? Each time numbers grow larger, without solving these problems, astronomy remained imprecise, engineering remained limited, and scientific progress slowed. Ancient India faced these same issues, but approached them differently. The turning point came with the development of the decimal place value system and, crucially, zero as a number. Indian scholars did not merely invent a symbol. They defined zero as a mathematical concept with rules. By around the 5th century CE, mathematicians like Aryabhata were using place value to represent enormous numbers with elegant simplicity. A few centuries later, Brahmagupta went further, laying down clear rules for how zero worked in calculations, how it behaved in addition, subtraction, and multiplication. This was revolutionary. With place value, the position of a digit now determined its meaning. A single 1 could represent 1, 10, 100, or 1,000, depending on where it sat. Zero acted as both a placeholder and a number in its own right, allowing calculations that were previously unthinkable. Mathematics became faster, clearer, and vastly more powerful. The impact was immense. Indian mathematicians advanced algebra, geometry, and trigonometry, developing methods to solve quadratic equations and calculate sign values with remarkable accuracy. These ideas did not remain isolated. Through trade routes and scholarly exchange, Indian mathematics traveled to the Islamic world, where scholars translated and expanded upon these works. From there, the knowledge reached Europe, reshaping global mathematics. It is no exaggeration to say that modern science rests on this foundation. Engineering, physics, economics, and computing all depend on decimal notation and zero. Every time you check your bank balance, use a smartphone, or rely on GPS navigation, you are benefiting from ideas first formalized in ancient India. If you are finding this story enlightening, this is a good moment to gently tap. Like or share, it helps stories like this reach more curious minds. There is also a lesser-known detail that often gets overlooked. Ancient Indian mathematics was deeply connected to astronomy. Calculations were driven by the need to predict eclipses, track planetary motion, and align calendars with seasonal cycles. Mathematics was not pursued for abstraction alone. It was a way to understand cosmic order. This practical motivation helped drive precision and innovation long before telescopes or modern instruments existed. Another common misconception is that zero appeared suddenly as a finished idea. In reality, it evolved gradually, refined over generations of thinkers. Early inscriptions show placeholder symbols, but it took time before zero was fully accepted as a number that could be manipulated mathematically. This careful, methodical development is part of what makes the achievement so extraordinary. It was tested, debated, and improved over centuries. Today, the influence of ancient Indian mathematics is everywhere, even if we rarely notice it. The numbers you are reading right now, the algorithms behind social media, the calculations guiding aircraft across continents all rely on principles. first shaped on palm leaf manuscripts and stone inscriptions. This is not ancient history gathering dust. It is a living legacy embedded in the modern world. As we look back, it becomes clear that progress does not always arrive with noise or conquest. Sometimes it emerges quietly, through careful thought and patient refinement, until the world realizes it cannot function without it. Ancient India changed mathematics forever, not by force, but by clarity of thought and a willingness to rethink the very nature of numbers. If this journey into the past has sparked your curiosity, consider following for more stories that reveal how ancient ideas continue to shape our present. History, when told carefully, reminds us that the future is often built on insights far older than we imagine.